Alrighty then, should be streaming, I believe, and same old routine, even though it's April Fool's Day. Yeah, same routine. Screw that. Anyway, just get these logistics done and then I'll be free. Look at that, it actually worked on its own. It's never done that. Huh. Very nice. Okay, so saved me a little bit of trouble. Alright, so in the comments, you should be able to see that. Disbar's lab is back. Anyway, I found an experiment video in which they crash a two mass going one velocity and a one mass going two velocity into a cookie, he says. Well, it's actually a saltine. So, it's bad enough that we can't get something close to a perfect thing like a spring. Everybody's got to do the stupid experiment with some kind of other retarded mechanism. Because springs can't collect energy for whatever reason. Who knows? I mean, the whole thing is just so silly. But yeah, we're going to measure it based on what cracks the cookie. So it's just like saying what breaks the glass, what splits the piece of wood in half. It's all this kind of voodoo, physics. Because, yeah, clearly it just has to do with threshold, right? You get to the threshold, then it looks very dramatic. So it's like just you could press on a wine glass, and just apply pressure and nothing happens. And all of a sudden it breaks and it looks very dramatic compared to not breaking. So what? I mean, it doesn't prove that there was a dramatic amount of extra energy. So it's just so irritating. Anyway, I measure the damage. Probably not the best object. Yeah, so why not just post the link as, well, here's another junk experiment done badly. And it's done badly, too. So on top of being junk as an idea, it's junk in the sense that they might as well be brozos doing it. They're such clowns. I mean, they're, whatever, school teachers. So anyway, that ends up related to another video he posted. So he didn't give me a comment for the other dopey video. Let's just see. I don't think he did. No. So he gave me a comment for the other one he posted on his channel. Alright, so you should be able to see this. Yes, maybe. I don't know if there's a great deal of point in making it bigger, but I can do that. Alright. Just this part. Alright, so it's just carts again, okay, and he rolls them into each other, and so the red is the fast cart, the fast light cart, okay, so it's got one mass and two velocity. The blue is the two mass with the one velocity. Well, it has no velocity to start, so you're just crashing the light cart with the velocity into the heavy cart and transferring the energy. Now this is the Professor Lewin experiment, exactly. Alright, so the math says you should get 2/3 transfer. So you should be transferring 2/3 of the velocity. So this experiment came way short of that. I mean, it's a little, just 0.02 kind of thing, or 3, above being exactly 50%. So 50% is my prediction, is the maximum. It's a little tiny bit more than 50%. But you do have this rebound of the other car. Now, so anything goes below the red, this mean line is supposed to be reversals. Okay. So what happens here, the blue car doesn't actually reverse. It's just that it hits the end and then bounces back. So it hits the end right here, bounces backwards at this little tiny velocity. So clearly hitting the cushion at the end is kind of catastrophic, because you look at lost like 80% of its energy, which is sort of surprising. So this is where the two carts start to collide, right? Where the red line goes down, and somewhere after that, somewhere around here, is where the collision's over. Okay, and it's reached its maximum velocity. So the interesting thing is that it does this reversal. So this reversal is happening to the cart that hits, and it's a perfect reversal. I mean, there's not even a blip in that line. It's not like it slows down and stops and then speeds up. I mean, it's almost a straight line, which is, when you think about it, how can that be possible? It decelerates and accelerates at almost the same moment in time. Doesn't seem realistic. Well, anyway, the thing I found curious, right? The thing that really bugged me. So it's a shitty experiment in the sense the result doesn't come out their way, and it certainly doesn't come out perfectly my way either. I mean, there's this extra hunk of energy. This down here is above the 50%, so it is creating free momentum, in my opinion, because it's got something that's leaving with momentum, and it already gave away all of its energy, so nothing should be leaving with more momentum. But look at the slope of the line. It makes no sense. So the red line is the faster car. It's still the faster velocity. See, this is oh, I'm on the wrong thing. Sorry. Shit. Okay. I had to put the mouse in the right place. So many things to have to think about. Alright, so this line here, this is the light cart, the red line. Okay. This is the total collision, here to here. And this is the heavy cart hitting the end and bouncing back. This is the light cart reflecting, okay, going back in the opposite direction. But look at the slope of this line. So this is the light cart. So we've been talking about friction and how, you know, the faster you're going or the lighter you are, the less friction there is. I'd say that's an absolute fact that no one's ever going to dispute. But look at the decline of this line. There's no explanation. He doesn't touch anything. Nothing happens to make this line slope like this. It's sloping more than the heavy cart is. Look, it's a pretty consistent reflection off the wall. It bounced off the wall and it's coming back, and it's doing so on a slight decline. It's losing a little bit of energy. So a little tiny bit of friction going one way, big ton of friction somehow going somewhere else. So this, I would argue, the track is uneven. The only explanation is that this cart is obviously going uphill, and that's why it's losing energy so dramatically, is it's going uphill. And this cart, well, it has to be going slightly downhill because it should be losing more energy than it is. And then the other thing to point out is both lines stop right here. And you'd almost ask, why is that? Did they stop it from stopping, or why is it stopped there? Is that supposed to be where both carts stop? Because both carts do stop at about the same exact time if you watch the little video. And now you're saying, well, maybe this whole scale is broken. You know, maybe they don't have it calibrated right, because when it starts, it loses 0. You know, and this ends up being, this is actually the new 0 line. So it's sort of messed up in terms of it's not doing the units of distance correct. So anyway, junk experiment. That's all I got to say. It doesn't prove his argument, that's for sure. It doesn't come out the way it's supposed to. There certainly isn't 2/3. And the 1/3, this is 1/3 coming back, but why is it doing this? Why is it decelerating so rapidly? Because theoretically, these two lines should never cross, right? The heavy object, even if you gave them the same momentum, the heavy object loses its velocity much faster. 4 times faster, in fact. 4 times faster. So this blue line should be 4 times faster running to 0 than this red line. So those two lines should never cross. And the fact that they obviously cross, and rather dramatically, in the sense that the red line is losing energy insanely faster than the blue line. And there's no explanation for that. So again, it's just another experiment. So this is just like the professor. I mean, again, it's the same experiment as Professor Lewin experiment. Now we have another experiment that just seems obviously shenanigans again. Something's really wrong, fundamentally, in how this experiment is being conducted, because this line is theoretically impossible. It's implausible. There's no explanation for it. It shouldn't exist. Clearly, it indicates shenanigans. Alright, so that's that experiment. He does the opposite of, plowing the heavy cart into the light cart. And, that one you really can't tell just because you just make the numbers up. But it does come out perfectly consistent with what I would predict. Alright, anyway, what momentum would predict. Alright, let's get on to the cracker people. Yeah, so this experiment is pushing a box. Okay, so this is just another frickin' experiment where they're using gravitational friction as that's the part where you'll see it, a wonderful experiment. Second hand, of course. Alright, so they just crash a cart. You can see that. So they crash a cart into a cardboard box and push it. So it's just theoretically, you can understand all they're doing is put an obstacle in the way, and they're saying push the obstacle, and they're saying that that's somehow pushing a thing, across a surface is using friction to take the energy away. So, leave us go over that theory one more time. I've been over it and over it, but we'll do it again. Again and again and again and again until somebody responds in some coherent way to the argument being made. So I'm arguing that friction caused by gravity is a menace to observation because it cheats. Heavy things and slow things really get punished because gravity, in fact, does give heavier things more energy. They have more little matter bits. They collect more gravitational water, so to speak, and by more gravitational fluid, to use Benjamin Franklin's terms. So we're basically just talking about round objects, but you could just talk about the round object as if it was a bucket, okay? So the little bucket collects a little bit of water. The big bucket collects a lot of water, from the gravity. Alright, so obviously that a heavier thing would push deeper, more contact with the surface, more pressure between the two wires. I crank the screw to screw the two wires into each other. The more I smash the wires into each other, the more contact, the more capacity, right, for the water, to go into the ground. Alright. So the simple argument is, yes, lighter things, less friction, because they're pushing into the ground less per inch. Heavier things, more friction, pushing into the ground more, able to lose more. Bigger arrow, bigger arrow. Now, the same is true for if I just ignore mass, and I just have the same size objects. Alright, and all I change is their velocity. Now, the experiment I'm going to show, it's really, they're doing both. They're changing the weight and changing the velocity. But anyway, fix the lines a little. Alright, yeah, I'm not terribly, oh look, my lines have a slope. Not really. They're pretty parallel, actually. Just an optical illusion, people. Alright, so then we're just comparing two same things, so we're just going to give one twice the velocity of the other one. So one velocity and twice the velocity. And the fact is, the one with twice the velocity will in fact go, here's notches of distance, it will go 4 notches of distance. That's the expectation, frankly. That's what gravity will let it do, because it's going twice as fast. So we're right back to Galileo. Galileo says the first unit of time, you fall this much distance. In the second unit of time, it doesn't matter what the unit is. The unit can be 1 millisecond, 2 milliseconds, 45 milliseconds. It doesn't matter what the unit of time is. This is the proportions, how things move, how things fall in gravity. And the third would be 5, and so it's 1, 3, 5, all the odd numbers. Alright, so that's Galileo 400 years ago. And here I am still trying to argue that Galileo knew what he was talking about. So for the objects, so this one, the heavier, the slower one, this one only goes here. So you have this dramatic difference, 4 times the difference, in the rolling friction, and you only have twice the velocity. So how can twice the velocity be creating that crazy difference? And, well, it's because of this rule. It's not that complicated. The friction, see this distance here, so this speed, this goes from, you know, let's say we'll just use 50 miles an hour for half the speed, and so 100 miles an hour for at the full speed. This goes from 50 to 0 in this space. This goes from 50 to 0 in the same space. This energy will be exactly the same, okay, as this energy. This will do exactly the same. It's exactly the same experiment. This experiment and this experiment, exactly the same. So if I just filmed this, it would look just like this. 50 to 0, 50 to 0. And so you have to account for the fact that all of this, okay, is 100 to 50. Right? Now 100 to 50 should be the same as 50 to 0, right? But that's the trick of velocity. So obviously it's moving across the surface faster, which means it doesn't have very good contact. It's not connecting. And you can understand the faster I go on the surface of the earth especially, right? The faster I go, I can actually just lift off the surface and I'll never even touch the surface. So I go fast enough, I don't even touch the surface. There's zero friction. So you can sort of understand it from that simple argument. But obviously the less contact there is per inch, the less you can lose to friction per inch. So the same gravitational pressure, so just think of it as pressure. So I'm going to push on something with a notch of push, right? So I have a push here, okay, I have a pressure, and the same push here. So over this whole distance, so this is like the cracker argument, right? How much pressure you're applying over how much surface per time. So, you know, the higher the impact velocity, all of the energy has to go in immediately in that little tiny bit of time. And then the broader I do it, the slower I do it, I can take that pressure and apply it over a much larger amount of surface. So there's much less hitting per inch of the surface over time. And that's all that's happening here. So I'm taking the same push, you know, the same little push, and it's being spread over this entire distance. So yeah, it adds up to 10 pounds, okay, but it's 10 pounds over all of this. Okay, so obviously each little piece is getting hit a lot less, and here the 10 pounds is hitting every much smaller amounts of space, or being hit by the pressure. So it's the same kind of argument. The friction is taking only half the energy in this entire distance, where the push is pushing down and creating the contact. So over this whole distance, it has the same contact with the surface that it had in this tiny distance. And that's the reason why it comes out this way. But I mean, it's a really old feature, the 4 to 1. Okay, there it is. I mean, it's Galileo, hundreds of years ago, and here I have to defend it. You know, as something you should understand, that's what's happening in these experiments. Friction is not even. It is not a per inch thing that happens. Everything, no matter how fast it goes, it loses the same energy per inch. That's not how it works. This is like 8-pound bowling balls and 16-pound bowling balls. You can understand when an 8-pound ball going 16 miles an hour hits a pin, it can give the pin 16 miles an hour. The pin has a standard mass, you know, times mass x. Okay, so obviously when the, oh, it won't be, no chance you'll see that. I have to devalue this here. Send it down out of the way. Come on, you can do it, you little bastard. You bastard! Come on, this isn't complicated. Go. Alright. Alright, so it's an 8-pound bowling ball going 16 miles an hour, hits pin, it gives the pin at 16, you know, at least 16, you know, and it's times the standard pin mass. And then the 16-pound ball only going 8 miles an hour, you can understand when it hits a pin, oh, it's only going to give away 8 miles per hour to the standard X mass. So the momentum of the pins, each pin it hits in the beginning, it's giving away twice the momentum. So it's giving away twice a substantial amount of its velocity per hitting a pin. It's like it hit 2 pins. So when the 8-pound bowling ball hits the first pin, it's like it hit 2 pins. It's going to lose a lot of energy. 16-pound ball, no, it's just 1 pin, no big deal. It can keep going. So the 16-pound ball, obviously, you could argue, is going to be giving away less energy per pin impact in the beginning. But as soon as the 8-pound ball gets down to, it's only got less than half of its velocity left, then the 16-pound ball is going to start giving away more energy per pin because it still has more energy. It has more than half its energy left when the 8-pound ball has already hit half its energy. So, the lines will go something like, for the 8-pound ball like this, and for the 16-pound ball like this. Right? And so that difference is this difference will equal this difference. So the 8-pound ball wins in the beginning, okay, over the 16-pound ball, but in the end, the 16-pound ball is winning over the 8 in terms of giving away energy. But it all equals the same amount of velocity in the end, the same amount of movement of pin. So momentum makes perfect sense out of the bowling thingy. It certainly makes sense out of this. You can just understand that the faster object is losing less momentum to the surface. It's making it less hot. You can sort of understand that the faster, the lighter. I mean, I've done so many examples. The scale example seems a pretty good example. You could understand that if I am walking across a scale and I walk, I'm walking, we put the scale there and you have to run across it. You can understand that the faster you go across the scale, the less the scale is going to deflect. And the slower you go across the scale, the more of your weight will be registered. So, come on. It's too obvious not to say, yes, I understand that this isn't the best experiment, okay? Doing this pushing things in friction thing isn't the best experiment for trying to figure out exactly how much capacity to move matter in the universe these two objects have. That this test is not a very good test because the faster I make this go, the less friction it has, the further it goes, and I just perpetuate the illusion of the bullet in the gun, right? I just validate a bad impression that somehow the idea of Newton's equal and opposite is easily broken, and you don't care to even mention that fact, but that's what you're doing when you claim the bullet has 2,000 joules of energy and the gun's recoil only has 2. Alright. So, with that context, we must return to the silly push the cardboard box experiment. Alright, so this is the one where they, well, there's no, I'm not going to show all of them, but just you'll see what happens, right? It's just going to go 4 times as fast as it went in a previous experiment. And that's what he's going to show.
Thanks.
There. So in the previous one, it barely went here. So at half the velocity, it just went 10. And at twice the velocity, it went 4 times the distance. So it's just showing you the same friction argument. They really didn't need the cardboard box. They could have just let the cart run out of energy, but that takes more distance. You can't, it's not as easy to film if you let the cart go 20 feet. So putting the cardboard box in the way just allows you to create more friction, which just makes it all happen faster in a smaller amount of space. And so that's all this is doing, but it's really just telling you what does gravitational friction do to objects with velocity that are in contact with the surface they're being pushed into by the gravity. So just understand, the gravity is a per time thing. It pushes a certain amount. There's a certain amount of weight. So when I go fast, I only collect the amount of rain that was falling in that amount of time. So over that big distance, I collect the same amount of rain, if it was rain, that I collect in this small distance, because these are the same amounts of time. That's, I should make that more dramatic. The 3 to 1. yeah. All right. The same amount of time. Same time here, same time here. You can understand the rain. If I was collecting rain, I'm going to collect the same rain here as I collect in this small distance. So you can understand that the pressure for this side is going to be a lot less per square inch, because the bucket is supported by a much larger amount of space, and this is supported by a much smaller amount of space, so the pressure per inch is higher. I really shouldn't have to explain this to this is it really is having to argue with people who think they understand physics, and they really should be back in this should be a grammar school lesson, frankly. But clearly we see how teachers function, so we know why nobody gets right answers. It's because they're taught really wrong ways of thinking. Alright, so there's nothing here but just a, wow, look at that, it's 4 times. It must be, it has to be 4 times the energy, because it went 4 times further, so it has to be 4 times the energy, right? Friction's the same, right? So yeah, right. I mean, it's just that stupid, frankly. Alright, so these are the same chuckleheads that did the cracker experiment. So I think that should be here. So let's go back to that. And I mean, I don't know what to say. I mean, I should just mock this stuff, right? It's mockably silly. So they call it learning always. Now, they're not getting any views at all. So they, I don't know, it's just the YouTube thing. The whole Google search is so broken. Everything's so broken. But, they've been making videos for like a year, and their videos get like, 26 views. I mean, it's like, what? Even I think they should get more. Well, I mean, I think it's bad science, so I really shouldn't say that.
So first you're going to find the stitch fixed down.
And then they have commercials on it, which is really hard to understand.
Well,
so these are the two, tired physicists from some, I would assume it's grammar school, but I don't even want to think about it being a high school.
welcome to science class.
2 middle-aged nerds.
2 assholes. Sorry. You're worse than just nerds. I wish you were functional nerds, because nerds wouldn't have been this sloppy, frankly.
Doing science.
Yeah, I know, you're doing garbage, okay? It's garbage.
Everybody, so our big question here is trying to understand what causes damage. And we learned that kinetic energy makes peak force causes damage.
Yeah, blah, blah, blah. It's just stupid. All right, so there it is right there. They crash carts into a saltine. So somehow they think saltines aren't fragile like glass, where they just have a fracture point and then they break, they fracture, and pieces fly all over the place. Or they don't fracture, they just stay stiff. So it's just like you could just bend one, and there's a point where, oh yeah, it's catastrophic, right? It's doing just fine, and then it's catastrophic. And so that's all they demonstrate here, is that they can apply the energy, okay, in a form that breaks the elasticity of the cracker and causes it to fracture. And so that's their excuse to say, oh, this has so much more kinetic energy because it fractured the cracker, where the other energy applied just bent it. And therefore it's more energy. So the reasoning is pathetically bad. Well, then they do this experiment with a stopwatch. Can you believe it? So the guy lets go and he clicks on the stopwatch. So this is happening in less than a half a second. Okay? I mean, a third of a second in some cases. And he's doing that by hand. So even that theoretically is retarded. They're measuring the velocity based on the total trip, which is not going to be the real velocity at impact. So it's not going to be the impact velocity. Use that word at the beginning. The impulse energy. It's not what he's going to measure, you know. But anyway, so done just so poorly. So there's obviously no quick release. He's letting it go with his hand, you know. Just, yeah, let's just, you know, slop it together, fill out the form, you know, and then do this. You know, this is the Deschardelet shard, you know, charade. I mean, it's just, this is how not to do science, is to let's just make it look visually like an experiment, but we really won't analyze what's actually happening. And they also, you know, they have this cracker pushed against the card, so frankly it would be a little more fair if the cracker was suspended, all right, and that way there's a chance that the heavier cart could have broken the cracker. But yes, what will be seen is the heavy cart going half the speed doesn't do much to the cracker, okay, and you can sort of understand, well, that's like the recoil of the gun. It doesn't do much to the shooter, right, because of the distribution in time. The energy is absorbed over a much larger period of time, and it's spread over a larger area. Now in this case it's spread over the same area, so the bullet is the same size as the gun. It just contains a lot less atoms going twice as fast, okay, in this case. So obviously the impact difference can be observed, and that's all they do here, is create an experiment that creates enough impact that you are pushing in the glass in one case, and in the other case you're pushing fast enough to break it. Alright, Tim, I don't know if we can see a car here, but
I'm going to take that double mass car and smash it into the cracker. Let's watch.
there we go. So not much, few crumbs. Yeah.
See the
Not very dramatic. Okay, so they wasted a good camera doing slow motion for this junk experiment. So instead of doing a valid experiment like hitting a cylinder or a syringe, you know, something that might have some chance of showing you how much actual energy is absorbed. I mean, the obvious one is just to say use a spring, you know, but you could do what Brozo did. You can pull a weight. You know, lots of different ways to do it. You know, Brozo was too stupid to understand that the weight has to be heavier than the thing hitting. The pressure is to, you can't have too light a weight than the thing you're hitting with. The weight has to be heavier than the object that's applying the energy. But anyway, I mean, there's lots of ways they could have done this experiment that would have been fair to the experiment, but instead this. So this is worse than the stupid pushing the box experiment by far, in terms of this is just plain retarded. It's so stupid. Like everybody knows, crackers are the greatest way to detect energy.
Test the damage by putting a cracker up there, and we're going to run this car at 2x speed. Let's see what happens.
So it's just such bad science. We're going to test the damage, we're going to test the energy, I mean, it's really bad for kids to be thinking this is how you test it, is to just pick something that's fragile and then decide everything that cracks it has a lot of energy and everything that doesn't crack it has no energy. So yes, it cracked the cracker. There you go.
Again, this was original mass and double speed. It created this much damage, and so
that would all be superficial. So again, you could argue that's the same thing in a car crash, right? That a light object hitting your car can bust your plastic, crack a few things, but you know, it's not going to displace your engine, where the heavy thing going slow will bust your engine and push it into your driving compartment and all kinds of crap. So you could do the experiment in an opposite way to demonstrate the fact that sometimes slow application of energy will produce more visual damage. But it's just their choice to decide what they're going to use to do what with, but it has no validity as a scientific experiment. It's just baby talk. I mean, it's just, this is so bad. But these are school teachers, you know, these aren't people that are really experts in the subject they're teaching. They're just general teachers, and they just get assigned a subject. You know, it's not like these guys have any specialty in physics. They just read their little book and then spout the little words they're supposed to spout. But it really is poor form here. Alright, so those are the three. Thank you, Dispar, right, for just more noise. Thank you. It's always great to add more noise to the conversation. I mean, what will we do without the extra noise, right? I mean, it makes such a valuable, vital contribution to have a bunch of noise. Alright, see if there's any commentary and such. Where do I go for that anyway? I'm not sure. It's probably this over here. No, it's probably this one over here. What does that mean? Giles Oni. I don't know. Gillies Oat. I don't know. Fuck people. I don't get it. What does that mean? Alright. Then J. Troy Doe. Good morning. Okay, well, whatever. Not very useful commentary so far. You could say something like, this bar's a jerk. Yeah, I like that. You know. They're all a bunch of skanky cunts. Like that kind of. Anyway, yeah, so I guess we'll go find some of the dopey comments. And they're just going to be, again, they're just so stupid. I mean, there's nothing to defend here. It's just so frickin' bad as science. I thought I had it already loaded. I guess I have to go find a spar. Well, we'll just go to the comments, and then we'll just go to his channel. That's the way to do it. Alright, so these are the two videos he linked. So this one is the Professor Lewin garbage experiment, right? The free momentum experiment. There's nothing else to call it. If it comes out the way they want it to, right, the way their math says, you end up taking something that has 100 momentum, okay? It has a mass and a velocity and a momentum. And these are people saying they believe in conservation of momentum, right? They put it into the experiment and it comes out with 133. Yeah, it's twice as heavy, but it's, you know, it's 133 momentum. And then there's 33 going this way coming out. So the experimental box, you put 100 momentum into the experimental box, and the box produces 133 that way and 133 that way. So you end up with 166 total momentum leaving the box. And that seems rational to the people I'm arguing with. That seems a reasonable thing to expect our three-dimensional universe to do, is to have 100 momentum go into an experiment and 133 to fly out that way and 33 to fly out that way. It really doesn't matter which direction it is, right? It's all momentum in the universe. It's energy in the universe. So clearly it's a free energy theory. And here they are defending it. You're just, what? No, they're not that stupid, are they? Yes, they are that stupid. So, thankfully, no commercial. For a change. Alright, only one comment. So that's interesting. Just one comment. Thanks for letting people know. So, again, what he should be saying is, gee, this is disappointing that all these experiments are so noisy. They all got different numbers, and they all come different, they all blah, blah, blah. That kind of sucks. Shouldn't the science be more observable than this? Why are these experiments always rickety and fucked up? I'm sure newer videos will continue to come out as well. I wish I, could have that insurance. It'd be good if what we can do is provoke somebody to do an experiment that actually has credibility. That would be a nice change. A credible experiment. Gee. Alright, unfortunately, I don't think this experiment outcome is conclusive. Well, I mean, the truth could be that you're wrong and I'm wrong, but yeah, it doesn't seem likely. So yes, the result is sort of in the middle of the two predictions. So obviously not of much value for either case. It seems just isn't a perfectly elastic collision, so there's no explanation of how that would have changed anything. But anyway, however, it's worth noting that times 5 times blah blah times 1 divided by, I don't know what that is, less than 4/8. So the 4/8 is the velocity of the beforehand, and the 2/7 is the heavy car's velocity. So you can see 2/7 is only 0.03 more than exactly half of 4/8. 24 would have been right on, and it's 27 instead. So it was pretty close to being right on 50%. But obviously the extra blah 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 is the problem. I will be coming out with videos explaining why Gary's notion of momentum is completely wrong. So again, how can you have a notion of fucking momentum? I mean, it's so elemental to the actual physical substances in the universe. Mass and velocity. How can anybody have an interpretation or, a notion or anything? I mean, it's mass, a number of atoms, electrons and protons, moving. How the fuck can you have a notion of that? Shit. Amazing. You're the people who don't think it's a thing. You're just saying it's not energy, so therefore it's nothing. It's a meaningless observation. Oh, momentum, meaningless observation. Doesn't really have anything to do with anything. Because clearly, when you're squaring the velocity term, you have to always appreciate that every time you say momentum, well, who cares what the mass is? What's the velocity? The velocity is everything. All right, anyway, which is the source of his confusion. So again, there's no confusion here. I'm saying, could you show me a piece of credible evidence? And apparently you can't. Yeah, he is simply flat out using the words differently. So again, more nonsense. Why don't you use Galileo's 1-3 relationship and apply it to your own judgment, and maybe you'll get the picture that, oh yeah, the same thing happens in the 3 unit, in the 3 distances that's happening in the 1 distance. That means it's more pressure. Oh yeah, same pressure applied over 3 times the space. I should expect a different result than the same pressure applied over 1 unit of space. Yeah, I should expect those things to be different. Alright, anyway, using the words differently than how the rest of the world uses them. Again, this isn't about the rest of the world, but it's about how scientists use concepts, and I would argue that I am glad not to be among you. I'm glad not to be among the believers in bent space and dark matter and neutrinos and superposition and magical ESP entanglement. I'm glad I don't have your fucking insane notions of reality. So, fuck you. Alright, surprisingly dull response. For 65 views, this is a pretty dull response. I mean, where's the Falwells? Where's all the assholes? Where's the Brozo? Where are all the comments about how, oh yeah, that sure proves it? When, no. Yeah, no. Not quite right. So he says, it is not 2/3 nor half the velocity. Oh, it's so damn close to half. So that's just being a little bit of a cheater there. It's certainly nowhere in the middle of half and 2/3. It's almost perfectly half. So you're really cheating the truth there. But anyway, what else is new? Alright, let's see if the second video. So this is the cracker video, the one you would expect there really to be no comments on, because it's like, why are we bothering with a video this stupid? No commercial. Yay. Alright, only 2 comments. So they really are going nowhere here fast, I guess. Good find, Dispar. So, these people, yeah, there should be more people timing things with their stopwatch and letting things go with their hands and, measuring velocity over a total distance, because that all makes great sense. No, it doesn't make any sense. Well, it's not super precision. The results are more than evident, la 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 la, to morons. Alright, so now he comments to his own video. That's funny. In both cases, according to MV, they are equal. Yet the faster, lighter car does indeed cause more damage. And again, that is perfectly consistent with understanding that slowness of a weight means that, yes, it will distribute its energy over a larger period of time. The faster something's going, it will distribute its energy very quickly. The slower it's going, the more time it will take for its energy to be distributed. How the fuck can you morons not understand that? Yes, bullets look very, very energetic because they apply all their energy in a much shorter period of time. It's just amazing. It does more work. That's the whole point we're trying to get to. Is it more work? Is it show, okay, and blow, and just shit, or is this the real definition of work? Is some visual effect? And I would argue that if scientists should be able to say, "Oh, come on, we're not stupid enough to be fooled by this." But apparently they're not willing to say that. Okay. Yes, an interesting video, but surely they cheated the result, just like Walter Lewin. So this is amazing. I mean, this guy is just so dishonest. I mean, he can't even concede that the result was a piece of shit. It's a fucking cracker, retard. I don't even think he's commenting on the right video, right? The cracker video isn't the Lewin experiment, so he can't even pick the right video to apply his comment to. This is the cracker video. Alright, so, bravo, moron. You put your comment on the wrong video. But you know physics. That's for sure. I've shared the link with Draft Science. Right, this is the crack. So, yes, how exciting. I'm so fucking compelled by another noise experiment. Gee, bro, you're really helping, Dispar. Just keep at it. Just keep trying to find every crappy example of the fucking experiment to sit there and just muddle the air. Just make the water muddy. You proved you could do that with your muddy experiments where you got a different result every time you did it. So just keep being a fucking asshole. Okay. I'm sure you will find it crappy. Well, why shouldn't I find it crappy? Everything about it was done crappily, and the whole subject was crap. Let's use crackers. You think that's fucking science? Let's use crackers to see how much energy it is. Why don't you stick a frog there and see if the frog goes ouch? But for the moment, I can't find a better video than this. And you can't understand that maybe you should be ridiculing physics for that. The fact that they've been saying this bullshit for 350 fucking goddamn years. They've been saying it takes 4 times the energy to go twice as fast, and they can't produce a single fucking experiment, a fucking single cracker experiment showing us that to be true in 350 years, and here you are ridiculing me? You can't see what a gaping, stinking, skanky cunt you are? Amazing. You fucking weasel. Oh, I'm just an honest observer. Fuck you are. Alright, let's see if this Gosling cunt put up anything different. God, these people are such pieces of suck. I guess I might as well just go to his channel. Same thing, okay. Just the same old video. 46 views. Let's see if there's any extra new comments or anything. No, just 3 comments. Good to see more subs. So, like, Broso's really interested in this whole subby thing. I mean, he's really fascinated by, how many views and subs. This is all like part of the fun for him. So pathetic. God, I just hate this planet. Oh, let's just see. Maybe we'll see if Brozo has anything new on his moronic dirt channel. No, he just yeah, it's this little complaining letter. YouTube doesn't let me post my comment. It's such a relevant comment. I have to post a whole video about it. Where he defends, okay, right in this comment video he made, he defends not bothering with quick releases. Quick releases are a bad idea. It doesn't make any sense at all. Why would you have a quick release? That's a silly thing to do. Alright, so, well, since I'm still here and there are no comments, I guess I could. We're almost at the, big fun of the, the, whatever it is, the John Chappelle Crazy Society. So maybe I'll try to find their video, right? It should be here somewhere. And, let's see, where the hell is it? It should be here somewhere. Let's see. Oh, wrong. Not there. Not there. It should be here somewhere. I can't even watch these Kathy things anymore. She's just gotten so full of herself. There it is. Okay, John Chappelle. Let's go there and see what's. Well, I guess I can go to this video and it should do something. Tell me that I'm waiting. 2 minutes and 22 seconds to the big event. Alright, so let me make that a reasonable size for you. Let's see. Should be fixing that. It's still a little too big, I guess. That'll do. Alright. So we'll see what happens there. Probably take too long. I mean, they don't say much for the first 15 minutes or whatever. It's always kind of a, oh, that's us. You remember us? Yeah. We do these things where we just talk this shit. We just invite somebody to talk some new kind of shit because we like to just, keep talking all kinds of different shit instead of resolving anything. They ought to just do one subject and just beat it to death and then acknowledge that, well, we can't agree, or something. But it's all this, scatter shooting. So it's not very useful. Alright, so we'll see what this guy is. Let's see. New light is shown on special relativity, quantum mechanics, gravity, cosmology through analysis of the behavior of subatomic particles in a fluid condensate. Whatever that even means, right? Through strong coupling with EM fluctuations. So that doesn't sound too good. Repolarization, whatever that would be, and readmission at speed c. Dr. Peter Jackson is an astronomer, physicist, and architect. Whatever. I don't know. I mean, who knows where, maybe you can get lots of those degrees in some other country, but I don't know. And is a student mentor at the university. A student mentor. So he has those kind of degrees, and the best he can do is being student mentor, whatever the fuck that is. Ooh, spooky kind of language, frankly. At the University of Kent at Centerbury. I've never even heard of Centerbury. And is a fellow of the Royal Astronomical Society. I suppose they probably let anybody in who has $50, but whatever. I shouldn't disparage automatically, but whatever. It already sounds like crap. Through strong coupling with EM fluctuations. Yeah, that doesn't sound like anything real. Alright, discussing the apparent implications of free fermions, oh, fuck you, as vortex pairs and more. Oh, how exciting. Fermions and vortex pairs. Shit. I mean, that can't be real. Whatever a vortex pair is, that isn't real. You know, what a pile of mush. Ugh. Puke. Oh, look, there's Andrew Castro. Doctor. Why don't you put doctor in front of your name since you're a doctor? Dr. Andrew Castro. The NASA scientist who makes sure their astronauts don't get overly radiated. He's a radiation specialist. Da-da-da-da. Has about 6 brain cells. Anyway, coffee and chocolate to begin with, and activate neurons. Waiting for morning show. Ugh, this is somebody with like 3 names here. Semibeppa, Hippocora, blah, shippe. You're fucking retards everywhere. God, I hate this planet. I really do hate it here. It's really disgusting to be among you. As the alien would say. Adam Lore. Okay. Oh, cool. Now I don't have to choose between graph science. Yeah, well... Oh, yes, I am going to save you the grief. Yeah, the horror. I can't watch the John... I have to watch it always after it's over because I have to double the speed on it because that's the other thing. They're all old farts and they just drone on and you're like, oh, come on, I just can't. It's so tedious. Ah, it's raining here finally. Ah, rain. All right, so I guess we'll stay here and see what happens.
Today's CNPS technical session.
Yeah, it's not very technical.
These are the so-called alternative sessions that we have to the main sessions, which are, fundamental discussions on physics questions.
Blah, blah, blah,
we
blah,
had
blah,
last
blah,
week, for
blah,
example,
blah, blah.
If we had a receptive audience generally in the world, how would we best use the time available to explain to them problems we foresee in physics?
What you should do is be
now these
percolating
technical
it down
sessions
to
are
the
more
essence, the
detailed.
stuff you can agree
we look
on.
at specific aspects and maybe go into a bit of mathematics and so on. So we're not shy of doing that. Even though it's April Fool's Day today, I hope we will be not giving any evidence for that at all. Now let me just introduce
My father's
today's
birthday.
speaker. So
Fondly remembered.
actually, we were first introduced to Dr. Peter Jackson, who is an astronomer, a physicist, and an architect, indeed, and is actually currently a student mentor at the University of Kent at Canterbury, and is a fellow of the Royal Astronomical Society.
Blah, 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 blah.
Now,
That's all I know.
some people, in particular, Dr. Dennis Allen, has been looking at a lot of publications, and actually, Peter has been quite prolific in publishing in ResearchGate, which actually is a tool that Denny has used himself. So Dennis brought to our attention, I suppose, in the first instance, Peter's voluminous publications, and we had a look at them and so on. And then we made an introduction. And in fact, James Keane here gave us some lectures previewing some papers, including Peter's papers.
Peter's papers
And
picked a pile
in fact,
of pickled
that
peppers.
talk that James gave a few weeks ago, Peter was kind enough to
Jeez.
attend.
Oh,
and,
shut
and
up.
actually, he was quite complimentary in Jim's analysis.
Okay,
of
we'll
ideas.
tone that down.
So,
I mean, anything I babble about
Today
would
we
be
have a
better
real
than
thing.
this.
Peter has very kindly agreed to talk about.
Fuck.
The central
Yeah,
thesis
it's just too
that
slow.
he has is called DFM, which
Right.
stands for Discrete Field Model. And I think quite a number of people, will be sympathetic to the idea of
Discrete field
discreteness
model.
rather than continuity. But it covers actually so many things. And I think Peter will be talking about that presently. And we say, in particular,
Andrew
new light
Castro
is
asks,
shone
where did he get his
upon
PhD
special
and
relativity,
in what subjects?
quantum mechanics, and gravity
Yeah,
and
why don't you
cosmology.
make that
through
known for
analysis of the
yourself,
behavior of
retard?
subatomic particles in fluid condensate through strong coupling with electromagnetic fluctuations, repolarization, and re-emission. At
And
speed C, which is the
hyperburloids.
vacuum
Don't
speed
forget
of
the
light.
hyperburloids.
So I think what's quite interesting is that there's an endeavor to integrate things. And in particular, we're talking about integrating the very large and the very small, which is a singular failure of modern physics in that they say, oh, different systems apply. And one system works very well for the
boring,
micro
frankly.
at the micro level, but it fails
It's
the macro
annoying
level
me.
and vice versa.
I don't know if it's annoying you or not.
So
but
hopefully
yes, I'm
Peter will
annoyed.
be able to clear that up. And I think that I've looked very quickly myself, and we had a brief session just now before starting. It's quite turgid material. So I think Peter might be, giving an overview of it with the slides and maybe saying, look, I can talk in more detail about any of these aspects in the discussion, which we have at the end. Because as usual, our aim is to have a sort of a 50-50 presentation
All
and
right, well,
discussion,
we'll
maybe
come
sort
back
of roughly
to
an
this.
hour
And
presentation
I'll
and then an
do
hour
some
discussion and
other
Q&A.
crap, frankly, because this is just too boring. All right, so let's do this entanglement video, okay? Because at least it's much quicker, and it gives you some insight into the bullshit that is entanglement. So that's pretty useful. All right, so this guy asked pretty much. So this is 8 years ago. Dr. Ben something or other. Blah 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 blah. He's a nice enough guy, but just he wants to create all kinds of capitalist ideas. I don't know what the fuck this crap on the wall is. That's supposed to be art, I guess. Bizarre. Anyway,
Jacques does and how he actually does it. So Jacques, tell me a little bit about how you build your entangled photons.
So we want to get entangled photons, right? And the way we do that is via a process called spontaneous parametric down conversion.
okay, right. So it's kind of silly, right? Because we know spontaneous isn't a very scientific word. So that's just kind of baby talk right there. Okay, parametric down conversion, whatever, blah, blah, blah. So this is the crystal crap they use to make the two photons that they pretend went through slits or something.
Okay, that sounds loads more complicated than it actually is. It's really simple. It's just a process whereby one photon splits into two. So I can show you how we do.
Right, and so it's kind of just this obvious argument that you have a high frequency photon, dot, 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 and you're going to make two photons that are dot, 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 and dot, dot, dot. And they're going to come off at 45-ish degrees, well, I think it's more like 33-degree angles out of the crystal. So you have a bunch of photons going in, and you're going to create two photons that are essentially you're making out of one of the photons. So one photon goes in, clearly the electrons are hit in the same way coincidentally to preserve the pattern of the photon, and what you're basically just doing is splitting the frequency. You hit the electron this way, and then you hit the electron that way, and then you hit the electron this way, and then you hit the electron that way, kind of idea to divide the frequency into two twice the wavelength photons.
That over here, right? Because we get a big laser beam, we fire it at this crystal. So there's a special type of non-linear crystal. When you put light into non-linear materials, weird things happen. Okay, and in this particular one, two photons pop up. So what are the important laws of physics? Right. Well,
So at least they have it coming out sideways like they kind of do. Blah 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 blah. So their argument is because this happens, these two photons are now connected for all time in the universe or whatever. They're entangled, whatever the fuck that means. Whatever, they are in a superposition. They don't know which way they're polarized. They have no idea. They're confused entirely, and they won't decide what they are until one of them hits something. Obviously, they're probably hitting the molecules in the atmosphere, but who cares? That doesn't out them somehow. But whatever. It's just too silly.
there's conservation of energy and there's conservation of momentum. So it's,
So, yeah, same thing, right? Okay, so he understands that photons have momentum, but whatever. It's just too silly. But yes, he's just pointing out that it's the frequency thing. So
imagine this crystal, this non-linear crystal. I'm going to fire a photon in it, and it's got some frequency.
So he should just say, we're going to fire an ultraviolet photon, and we're going to get two infrared photons out. You just, come on. The audience isn't that stupid.
right? It's got some wavelength. And that tells you about its energy. Okay, so its energy is then h bar over gas. Okay. And then two photons are going to pop off. That guy and that guy. Call them number 1 and number 2. And we know that energy force will equal energy afterwards, so the energy of these guys must add up to the energy of this guy. So the frequency of these guys is half the frequency of that one. Okay, so that tells you about the...
Apparently, it's not always perfect. Like, you'll get one that's 310 nanometers, and the other one might be 340 or something. But I'm not sure of that. That was said in some other video.
The energy of this photon tells you what the wavelength is going to be. So we pump it with 400 nanometer light, and the photons that come off are 800 nanometer.
All right, so 800 is well within infrared, so it's not visible light.
Okay, so you send a beam of light into this nonlinear crystal, and each photon that comes in then produces 2 photons coming out of it?
Not each one, some of them. There's a very small probability it's going to happen.
Right, so we know, so that's a key thing to understand, because you understand the way it's going to be made is by a very rare event where the photon is made of elements, okay, and in the crystal you're going to hit an atom with electrons in exactly the same position, essentially, and you're going to hit them when the electron's in the same position, and you're going to get an outcome that enables you to create this photon, that is, to duplicate this process. So that's why it only happens in 1 of a million photons. It's because it's not a common probability. It's an unlikely probability that you have that special circumstance where you hit it when it's in exactly the same position. You know, it's like a dog could be running around in a circle, and you're just going to throw a rock, and the odds are you're not going to hit the dog, okay? And you have to hit the dog 3 times in a row. So obviously you're going to have to throw a lot of rocks before you have that 3 times in a row I hit the dog. Not a very good example, but that's, that's what came up.
But because we've got a big laser that's got trillions of photons in it, you can make that probability appreciable. So we see lots of photons. Conservation of momentum, right? That's also very important. So if you look around here, right, our input photon is moving that way, okay? So what we don't want to have is 2 photons coming off here. That's really bad. That physics doesn't like that. So that's actually why we've got 2 prisms.
Okay, so I don't even know why he would say that could even happen. That can't happen. The photons do come out spatially separated, because you can sort of understand the whole way they're being created is by oscillations in the material. You're vibrating the material, the electrons are oscillating in a direction, and they're going to deflect the photons based on the oscillation you're creating in the crystal. It's a common thing, crystals oscillating, vibrating. They use it on almost everything. Okay, oscillating crystal is a common physics phenomenon, and it oscillates in a direction.
Bouncing light off here, the photons come off like that.
So at this point we've made our 2 photons by sending...
Now the trick is, right, they're going to use 2 crystals. So they have a piece of crystal where the photons are coming off like that, right? And now they're going to turn the crystal. And, the argument would be, well, now the photons are going to come off like that. So how are you going to capture those with the same mechanism? That doesn't make much sense to me.
Sending in this light into this crystal. Is this entanglement? Have we done it?
Well, not quite yet. It's not quite the...
See, it's no point in him saying that, because there can't be any difference. If I put a second crystal, it's not like I'm not making it the same kind of entangled photon. So they're just saying we don't know what their condition is. With one crystal, they know it's right and left-hand gloves. Well, in this case, they know the 2 photons are the same. They have the same polarization. So they already know they're fixed. And all they're going to do is create an experiment where they switch things around so they don't know what the outcome is going to be. So if one crystal, they get the same outcome every time. Same stuff comes out, so they're claiming it's entanglement, but they're really just saying to you somehow the only time there's really entanglement is when we switch, we create a confusion. Now they're entangled. So once we confuse the input, we pretend it's entangled when clearly that doesn't make any sense. You finagling the gun doesn't change the bullet.
Useful entanglement that we need to do something like build a quantum computer.
Yeah, right. So this guy's building quantum computers, which is kind of hilarious, right? Yeah. I mean, it's just kind of cliche, right? I mean, it's like he should be decorating April Fool's Day cakes.
Okay. Because to understand how you do that, you really need to know something a little bit more about this crystal, just a little bit. And the crystals care about polarization. Okay? They care about the way the light moves inside.
So again, they call this so many different things, right? They call this spin, they call this lots of stuff, and these are just polarization experiments. So they really do cheat the argument all over the place. He has this little drawing here of polarization, which is sort of interesting. He puts a triangle in it. That's kind of weird.
Yeah, right, so if I imagine I get a crystal, if I input horizontal light, the H, the photons that come out are going to be vertically polarized.
So we also know the filters work over a whole range. So the light doesn't have to be horizontal. It can be this, it can be this. 22 degrees on either side. So, this is all so fudgy, this conversation. But anyway, so the idea is the crystal converts not only the frequency, but changes the polarization. So it takes something oriented this way and makes it this way, or something this way and makes it that way,
So this is one type of crystal. Okay, I'm going to call this number 1. What I can also do is rotate this guy by 90 degrees. Okay, just take the same one, rotate it by 90 degrees.
So now he's just taken the filter this way and he's going to turn it this way.
Such that if I input vertical light, okay, the photons that come off.
Alright, so this is more mush because he's saying, okay, this is what happens when I put in this specific kind of light. Now, you can't put in both horizontal and vertical. That's not possible. But you can put in that 45-degree range of light.
Will be horizontally polarized. You get one of these and one of these, put them up next to each other, okay, crystal 1, crystal 2, and you input what we call diagonal light. Okay? Diagonal is a mixture of horizontal.
So you can't mix light. So the photons are either, polarized in one direction or in another direction, but you can't mix it. So that's just crap. And this drawing implies that you have both photons going this way, and photons going that way, which would be circularly polarized in a sense because you don't know which way the photon's going to be polarized. It could be any one of those polarizations. So that's pretty unclear of exactly what polarization of light you're putting into the experiment. But each photon has its own polarization. And a single photon cannot be polarized in both directions. I mean, that's just too silly.
And vertical. And if you get photons come out, you don't know whether they were created in the first crystal or the second crystal.
Well, you basically are telling us that you can tell because, frankly, the polarization will tell you because this one crystal is only going to produce the vertical when the horizontal goes in. Presumably, when the vertical goes in, no photon comes out, so it can't see vertical light. And the other one can only see horizontal. Can only see vertical and can't see horizontal. So one of them's going to block the other. And still has to get through the second filter. I mean, whatever the first filter creates, that light has to get through the second filter. So you do know that there's a lot less photons going to be coming out of the first filter because a lot of those photons are going to get blocked by the second filter. And the photons made in the second filter, obviously there's nothing that's going to stop them. So on average, you're going to be seeing a lot more photons coming out of the first filter than the second filter.
So you've got to say it's either horizontal or vertical. Okay? And that is an entangled state.
So mush. So this all comes back down to the fact that the outcome in the experiment ends up being exactly what polarization says, which is it's not 75%, it's 80%. You know, in a certain circumstance, you'll get 80% matches. And that's all understandable because the photons are changed as the polarization is changed, and that accounts for the little 5% difference, blah, 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 blah. So again, none of this has to be the way they draw the conclusions. So they don't really go into the rest of the experiment, so this doesn't have much more value, but we'll play it anyway.
So my question is, why can I not just try harder and work out which crystal my photon was actually going through? Isn't there some measurement I can do that just tells me and makes this just a question of uncertainty as opposed to a question of entanglement?
No, this is quantum physics, okay? This is quantum physics, we're dealing things with photons, okay? Now, in this quantum regime, you have things that are superpositions, right? And this is a
Superpositions. This is superposition, so he just tells us it is. So he didn't really answer the question, right? The guy asked the question, well, can't I just do a test? And he said, we could say no, we don't want to. But the fact is yes, you can do a test. But that's not what they're trying to do. They're trying to complicate the experiment enough to fool people into thinking the photons have ESP. Because yes, you could do a test and it would come out exactly as you expect.
position. Imagine you've got a coin, okay? If I take a coin out of my pocket and flip it, right, a coin in our classical macroscopic world, in principle, I could pause time and reality, and I could work out the momenta of every little bit of the coin, and I could work out the air currents that are moving around it, and I could definitely say whether it's going to be heads or tails. That's in principle possible to do, it's just really hard. But with a quantum...
Right, and this is exactly the same circumstance, except it's even really, really hard because it's a fucking photon. So yeah, it's not a coin. So, you know, so it's just so stupid. So instead of just acknowledging that, well, we can't see photons, you know, we can't even see them, even in a microscope. So why are we pretending, you know, to define when we can't? We can't follow the causes of the effects, but instead we'll just say that it's magical instead, because that's just more fun. But there's no logic to this at all. There's absolutely no reason to jump to this moronic conclusion. It must be magical because it's quantum and we say so, and it has to be interesting.
Coin with a quantum superposition, you can't ever know. It doesn't make sense to say whether it's going to be H or V, heads or tails. And that's the situation.
It doesn't make sense because it isn't heads or tails, because it's both, because it's a cat and it's dead and it's alive and it's blah, 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 blah. I mean, this is just, I don't know why people, ugh, this is repulsive. It's so stupid. This is worse than Jesus walking on water. I mean, this is worse. To come up with this preposterous exaggeration, this made-up theory of internal wackiness. I mean, I don't know how this appeals to anybody. Oh.
We've got here.
Don't exactly
So last
know
week we saw abstractly what
monstrous break was for. So he just sums up here and doesn't say anything. It just says, last week's video we did, so he probably just did the, you know, where they just make it into a teddy bear and Alice, and then they just, Alice and her teddy bear are entangled or some kind, you know, they make up some fake narrative to describe what this entanglement shit is supposed to be. So at least bravo for actually showing us, you know, at least the beginning of the experiment. You know, the rest of it just has to do with spinning mirrors so you can't tell which photon you're looking at, you know, all that kind of crap. So I haven't figured all that crap out yet. I haven't figured out all this beginning stuff yet either. I want to know what kind of light are you shooting in? Tripolarized? I don't know. What the hell is that crap? So that didn't make much sense either. So, all right, let's see what they're doing in the live room here.
Confound things even further, which I've actually derived. It happens when electron density reaches optical breakdown mode, which is 10 to the 23 per centimetre to the -3, when light EM won't penetrate dense electrons because the electrons can't vibrate, they can't fluctuate. So spacecraft re-entering Earth find at that plasma density they lose contact with NASA. And it's not until that density reduces again that they can again get radio transmissions. So that is OB mode. It's a well known in that field, optical breakdown mode, and that gives the LT. And in at CERN we find exactly the same. The power input to accelerated particles in the tube increases by almost the exact profile of the LT curve approaching C. So you can then put almost infinite power into trying to accelerate the particles even more, but the dense electrons created in both the bunch and the pipe frames in the LHC prevent it going any faster. So that's that can.
Oh, that sounds like absolute crap there, right? We can put infinite energy in. Yeah, I'm sure you can. All right, let's see if anybody in these little chats said anything silly yet. No, it's just this weirdo guy. Espacchio hexadential mental schegma. Smegma. Anything with positive and negative must come with a neutral as well. So says. So electrons are positive. I mean, negative. Protons are positive, and we need a neutral. There has to be one. Why? Oh, he says so. That's a good reason. Even neutral must come with positive and negative. So even that doesn't even make any sense. On and off must have none off. No, I don't think so. All right. North cannot pass to south and vice versa. Whatever that means. The poles have apparently switched. The magnetic poles. Which is interesting. But that switch can just be an electron pops off the top and a proton pops off the bottom. It could be that simple, really. To change the magnetic poles. Because the magnet is just a bunch of little magnets stacked. And the stacking really is just a polar profile on the surfaces. Pretty much. Alright, so no comments still by anybody, I guess. Unless you people have something to say, I will be on my way. Because, yeah, the Chappelle thing is just too boring to do live. Maybe if we were an hour later and they start doing their yammering back and forth, there might be something of interest, but it's really not that interesting. People with a bunch of complex and convoluted mush. Let's see how many people are in the room. So Saturday, not a good day for the Europeans. They were doing pretty good this week, actually. But they have failed me today. 10, well, it's not terrible. But, not very good either, but 10, whatever. It's funny. Where the hell was I? That's not... Oh, yeah, that's the place. Alright, so the 10 of you are going to have to start saying something. So 2-minute warning or so. Or else I will be on my way. I mean, you could just say something like, science should produce more evidence. Yeah, so that'd be a good thing to say. Experimental evidence. A lot of talk. Too much talk, too little experimental evidence. Well, there's Tim again. Instead of using a stopwatch, which they trigger by hand, one can set an iPhone camera to 240 frames per second. I don't think. Do you really think an iPhone camera can do 240 frames per second? I'm just not sure. and count the frames. Well, obviously, anytime you put down a ruler, you can do the frame counting, but as we've pointed out through past experiments, you really have to be careful of your camera angle. Many of the cameras do a wide angle lens, which distorts. So there's lots of things you got to look for when you're counting frames. And, you know, cameras say they do, like even cameras saying they do 60 frames per second, they're lying. Okay, they're not real frames. It's all interpolated and fucked up. So you gotta, you know, you can find the dead frames in the video, you know, where the frame doesn't change, you know, and it's obviously not a real frame. So I'm just saying, it's a little bit messy, frame counting. I'm saying if you got nothing else, that's, you know, I'd rather use a strobe, for example. So, I mean, I just have to commit to buying something, you know, because the strobe I have, it's like a camera strobe, and so it does everything in just 1 second units. So I can have it turn on and off 16 times a second, but it only does it for 1 second, so it's not very useful until, you know, unless I have the camera fixed to the experiment to start strobing at just the right minute. So I need a strobe that can be a continuous strobe. But obviously strobe photography is probably the way to go in terms of really getting accurate frames. But yeah, I mean, obviously using a stopwatch by hand is, I mean, look, they got numbers that were reasonable, but I just mean, what is the likelihood, you know, that you could really do this without you just learning how to muscle memory it? You know what I mean? Each time you just end up doing the same time because your brain just says, do that quick thing, quick thing, quick thing, you know, quick thing. So you just end up repeating it no matter what the speed is. You've muscle memoried quick thing, quick thing, quick thing, you know. So it is kind of just such bullshit. I mean, it denies a bunch of neuroscience besides just denying, you know, basic physics. You know, you don't use a human brain to measure fractions of a second. Really bad idea, because human brains suck at it. Thank you for the comment. So it's, like I said, it's an interesting subject, how you do all this timing stuff. The little, you know, defects in all of these timing methods. And as I showed in the beginning of the video, you know, the experiment with the huge deflection, you know, where the acceleration of the object dropped dramatically, you know, that's all you're really measuring, you know, is a moment in time. And it could be something else a little further along. So anyway. But yes, a strobe really would be a good idea. I mean, frankly, it's a lot cheaper than a high-speed camera, and it effectively can do the same thing. I mean, you can just take a long exposure photograph and use a strobe, and you can get the whole experiment in one photograph, and you know, it's pretty reliable. Thinking of making one mechanically, you know, with just a spinning motor, because I really don't need much, right? I just need 16 frames, 20 frames, something decent, you know, because if they're really perfect frames, I don't need the high frame rate. Do you think there is a specific reason rigor and the scientific method has declined so badly? I think the reason is that's what science became, is pop science. So it really wasn't about being an expert in science in general, doing science. It became doing specific, everybody started choosing specific specialties, like Faraday was magnets and electricity. Everybody became a specialist, and so they lost the connection to the big picture, that all the science adds up, into a whole subject, and that there has to be this devotion to creating rigorous evidence. But I guess part of it is that gimmicks worked. That's the game, right? Electrocute a kid, charge a kid and have the kid pick up paper, float the kid on a, suspend him above a bunch of little pieces of paper and have the paper fly into him. Why would you do that kind of crap, right? Because it's pop science. It's not real science. It's gimmick science, it's show science, right? Right. Tesla is like the perfect example, right? I mean, he's not doing anything that Faraday wouldn't understand, right? And he's, but yes, okay, so it's an innovation. He could create the giant lightning bolts. But again, he wasn't doing anything Faraday didn't already understand in terms of making them moot, in terms of their violence, okay, negating them with a Faraday cage. And, but he made it dramatic, right? He made it showy. And so it's all about the show, and not the go. And I guess that's part of how it got so loose, is it was really just about doing something that looked fascinating, not doing something scientific. So when you think of all the slow motion camera footage out there now, where they have a channel, slow motion guys, and they keep doing slow motion experiments that mean nothing to science, right? They keep doing ones that just mean something to visually fun. That's it. It's the Mythbusters. Why spend all this money crashing cars into each other? Right? You could just crash 5-pound things into each other, do exactly the same experiment. You don't need to crash real cars. Right? But it's all about the show. So, and that's what happened back in Newton's time, frankly. After Newton, somehow science got loose. The institution broke down, right? So the established science institution sort of didn't have any money. It really didn't go anywhere. After Newton left, you don't even know who ran the place, right? The Royal Institution. Who was the head of the Royal Institution after Newton? Who the fuck knows? Right? It disappeared as an institution, as a meaningful institution. And so there was nobody checking and balancing. There was no place to go where all of this science had to be scrutinized. And so I guess you could argue that's where it started to fall apart, is there were no referees, no science referees anymore, where things like the Royal Institution were a place where all the papers had to go and be attacked, tested. That's it, tested. So there was no place to test anything. So then that, the Chardonnay woman could do these stupid clay experiments, and apparently nobody showed up. There was no mechanism to show up and say, there's a theoretical problem with your experiment. It's a round object you're penetrating the clay with, and if you only superficially dent the clay with the round object, you'll get a distorted perspective because the round object is pushing down more than it's pushing sideways for one case of the experiment. In the other case, it's pushing sideways more than it's pushing down. And that inequity will create a difference in the clay yielding. The clay will yield in one case more than the clay yields in the other case. So it's not a very good experiment, right? But there's nobody there to say that. And apparently no one showed up later. No one examined the experiment. No one thought about it except for me. Because nobody had an incentive to think about it. Because they all believed in the kinetic energy theory. So they didn't bother saying, well, did we really prove this? I mean, nobody in physics right now is sitting there saying, we have no evidence that it takes twice the fuel to go twice as fast. They all think that we do. I mean, they all think it's not a subject. You know what I mean? They think that it's already there somewhere, that this is already proven somewhere, even though it isn't. So it's kind of like light being bent by gravity, twice as much. They sort of think there's some sort of real experiment that actually does prove that, when there actually isn't. So who to blame, right? I mean, the fact that they do not allow, because everybody who's dissident against their science is just called a nut. That's part of the problem. Now, a lot of them are. 99.99999% are assholes. But the fact that there is no scrutiny, I guess, is the key point. There's no willingness to indulge in critical arguments, to accept the critical argument and then produce, like I said, I can't challenge them to produce the evidence. That should be really easy to do. It should be really easy to go up to any scientific paper, to any assertion made by science and say, show me. And they don't allow you to hit the show me button. There's no show me button. There's just, I will argue it from mathematics. I'll argue it from some other bullshit, but I will not show you evidence. So I'd argue it can't get any worse than, again, Leibniz overtly, did it. I mean, it wasn't a hidden agenda he had, I mean, he wanted physics to include God. And, that agenda is sitting right in your face. He was attacking Newton's physics because it was too atheist in his opinion. Descartes and Newton were too atheist. Even though Descartes was a Jesuit and Newton was believed in angels. Great points. I think the more time that passes, the harder it gets to convince enough people that we need to get back to reason and basic foundations. I think eventually, just like the idiocracy will blow up in everybody's face, this will blow up in science's face. The fact that they haven't done any rigorous foundation work, the fact that their foundation is quicksand, it's garbage, it's mud, it's going to show up because there's not going to be any quantum computer. There's not going to be anything valuable coming out of their science because all of their science is now so lost in bullshit. I mean, they're all devoted, all the money is going to quantum kookery, and it won't produce anything of value. And that's going to be realized eventually. And then it's going to be, they'll say, well, how could we all fall for this entanglement bullshit? And they'll realize, well, we fell for all this other bullshit too. So yeah, whatever the reason is, it's deeper than, just. Yeah, well, this bar, you can say you find it frustrating, but you don't say that in your videos. All you do is ridicule my judgment that the evidence sucks and sort of point out that, well, Gary will just say it sucks. Well, yeah, of course I'll say it sucks because it sucks. You don't fairly critique these morons who do these shitty experiments. You only critique me. All right, so I'm just going to take you as an enemy of the process of forcing science to do better. You're not really forcing it to do better. You're endorsing noise. I mean, you really didn't make 2 videos saying, here's 2 science experiments that absolutely suck. Did you do that? Or 3. I found the 3rd one. The box pushing experiment. Did you say, here's 3 examples of experiments done as badly as you can do them? No, you didn't say that. Alright, that it's so hard to find accurate experiments with professional equipment and with intention to focus on absolutely prove kinetic energy. Well, I don't care whether they prove that. They're not proving anything with quality experiments. I'm going to prove that this entanglement mush, is absolute mush, because no one will detail what the experiment actually is and what the moronic assumption is. Right? The photons are only entangled because we confuse ourselves by putting a second crystal in there. How does the second crystal create entanglement? I mean, it's just too silly a proposition. We confused us, and by confusing us, we entangled the photons. Isn't that all they're saying? I mean, the fact that physics won't make any commitment to anything, right? I mean, what do springs measure? Will they tell me what a spring does? Does it produce momentum or does it produce kinetic energy? What does it produce? I mean, obviously the two things are made out of exactly the same thing, mass and velocity. You really have to say which one is it producing. Is it producing mv squared or is it producing just mv? Because you won't get the same answers. You're not going to get the same amount of energy depending on what weight you put in front of the spring. You're not going to get the same energy, quote unquote. You're going to get the same momentum. I mean, the question, I guess, is just that simple. Why don't springs conserve kinetic energy? Or if they do conserve it, show me. Show me twice the compression only producing 1.4 the velocity. Show me. Ah, the empty feeling is here. Ooh, the empty feeling. Ooh. He's creepy, you know, because he does show up at all the worst times. The old empty feeling. Oh. Ooh. What a boner killer. The empty feeling. Anyway. Okay, it's an interesting screen name. But it's just kind of a disaster for a smart person, reads it and just, oh, ooh, empty feeling, ooh. So you have lots of subjects. You got friction, and you got momentum, and you got kinetic energy, and you got cardboard boxes, and you got crackers, and your people aren't saying anything. There's glasp and gloop. I don't know what glapes and gloop. I know what gloop is, but I don't know what the other thing is. But yes, it is bullshit. And it's proven in space. Again, I mean, all these places you can prove it just doesn't... How do you make any sense out of it? I mean, you really, it's just about mass and velocity. No squared function. It's how much mass I shove out of my spaceship at what velocity. That's all that's going to matter. There's no squared function. I can't make small things going fast make more thrust than big things going slow. Same thrust. Pushing away my big shit is going to do the same turning power as blowing, farting out the window. Same difference. Just how much mass, how much velocity, times how much velocity. That should be enough of an argument, right? I mean, that realistically should be all the argument you need to hear, is that I can perfectly land a lunar module on the moon with just momentum. That fact should be enough for everybody to say, I get it, okay, we don't need kinetic energy. I contacted the local scientific institution, waiting for a response whether or not I can use their equipment, their experimental equipment. Yeah, we have to have the right experiment, that's the trick. And you have to have the right equipment, so yes, it's a double-edged sword. I mean, it's still, being a good scientist still takes a lot of, you have to, like I said, I mean, you can just do these simple things like, oh, I'll just roll the ball down a ramp and that'll be all I have to do. No, you have to figure out, well, it's more friction if it's heavier. It's more friction if it's not made out of the right materials. I mean, it's you found out, right? You say to yourself, well, what's slipperier than ice? Well, nothing's slipperier than ice, so I'll use a piece of ice. But then you find out, well, the ice melts and it creates water, and the water creates a vacuum, and that makes the thing stick. So it doesn't work. So it has to be ice that never melts. or it doesn't melt much. You know, such a tiny fraction of it melts that it doesn't create any vacuum pressure. I mean, it's all complicated. I mean, I wish it was really simple, but it's not. And yeah, so it really has to be done well and has to be done carefully. But you could almost argue that the fact that Professor Lewin, you know, he has little helpers and all this kind of stuff, and the fact that they couldn't get it to work without cheating. I mean, it is a fact. They couldn't get it to work without cheating. I mean, it's kind of obvious. That's sort of a demonstration, you know, that maybe there's something wrong with that equation. I mean, the fact that it creates free momentum should be the first thing they say that's a problem. But whatever. I don't even know how that kind of jargon holds up, you know, that whole scalar vector thing. They just declare it, right? There's no physics. There's no physics argument that says kinetic energy is a scalar, whatever the fuck that means, and you know, momentum's a vector. There's absolutely nothing to do that except the physicist wanting to make these silly assignments so they can have a loophole. You know, so somehow kinetic energy doesn't have to worry about what's going the other way, but somehow momentum does. You know, and it's like it was engineered just because the experiments weren't coming out right. And so they had to figure out some reason why, hey, how come, you know, it doesn't add up? And it's just a gimmick to make it add up. I mean, to pretend the kinetic energy of a locomotive isn't clearly in a direction, one fucking direction, isn't that absolutely silly? To say its kinetic energy could be going up, and it could be going backwards, and it could be going this way, and it could be going that way. No, it could only be going the way the train's moving. I mean, it's such a pile of shit. Let's see. No, I don't provide a counter argument. I admit I'm not capable enough to do that. I consider myself as a provider of experiments. You know, how crappy they may be, unfortunately. Well, I'm just saying you can see yourself any way you want. I'm just explaining why I see you as just a menace to my purposes. Okay? I don't see you as helping to clear the water. You're just throwing more mud in the water, and that's my enemy, is the mud. The mud is what's stopping everybody from seeing the obvious truth. And you're just helping make it harder for people to see the obvious truth. Do you think it requires 4 times as much fuel to go twice as far? Yeah, well, I'm just saying, do you really think they're ever going to prove that one? Don't you realize the only reason why we don't have that proof is because it doesn't fucking happen? Isn't that the logical deduction that in 350 years they haven't provided that proof? Because it doesn't fucking happen? Why haven't they repeated the Eddington experiment? Because every time they try, it doesn't work. It seems the obvious answer. Then of course they've tried it. But yeah, I mean, it's just that simple. I mean, the 4 times fuel thing is just, you just can't understand why they have no experiment with a spring, with you know, a water gun, with any kind of launcher you could come up with any kind of thing moving. The fact that they don't have a single experiment, and every experiment shows the opposite, right? And especially in gravity, right? Because your fuel economy gets insanely better the further you try to shoot, right? The farther you try to go in gravity, the better your fuel economy gets. You know, I mean, it just gets outrageously better, okay? Because you're in the gravity so little time. You're defeating gravity by limiting how much time it takes you to get there. So the faster you can get to a place in space, out in orbit, the faster you can get there, the less fuel you have to actually use. You know, you have to use more fuel, obviously, to go twice as far than half as far. But, I mean, per mile, you gain so much advantage. I mean, so the indications are opposite. The faster you go, the more energy you're going to take advantage of. I mean, the less energy you'll have to oppose, I guess would be a better way to say it. Let's see. Someone the other day said there was a hippocampus satellite. Yeah, right. He brought that up, and I actually went to the trouble saying, I remember I heard of that. This is the stupid moronic crap they used to create that fake black hole image. So this is just that whole bullshit. Of spreading satellites all over the goddamn place and then saying blah, 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 blah. And bullshit. Something that supposedly repeated the ending experiment. I couldn't find it. Yeah, I couldn't find it either. So he obviously is referencing the wrong experiment. So it was really quite useless, except to point out the fact that this satellite does take energy measurements from stars, and the fact is it can't tell whether the light went through the corona of a sun or it didn't. So, I mean, it can't tell the difference. So, obviously, if it can't tell the difference of whether this light went through the corona or not, that's obviously polluted data. Right, because we know the corona will bend light. All right. So, yeah, just so bad. Should it be the goal of physics to explain fundamental constants? I'm not a big fan of this whole constant worry. The constants are, what's the problem? It doesn't mean anything. We know that the speed of light is a speed, okay? We don't care whether we call it seconds, months, or years. Who cares what you measure it in? We know there's the idea of mass exists, okay? So there's a quantity. You call it a kilogram is the thing you'll measure everything against. Who cares what the unit is? Who cares what you make all the other comparisons to? So it's like the value of $1. Who cares whether you say how much does a bag of wheat cost, or how much does a bag of corn cost, or how much does a bag of jelly beans cost? Who cares what you tie the dollar to? It's all the same. Let's see. And if we explain them, I guess they are no longer fundamental. So I guess, whatever. I'm saying fundamental isn't the right word. Elemental should be the word, right? So you're just saying there are elemental functions in the universe. So mass is an elemental function in the sense that I would argue electrons and protons account for it. All right? And then when you go to energy, I would argue that the quanta of motion, that is the smallest little bit moving the speed of light, that's a quanta of energy. It's fundamental. So there's a certain number of quantas of energy in the universe moving around at the speed of light. There's a certain number of electrons and protons in the universe being pushed by that force. And so there's your elemental constants. That's how I would look at it. Let's see. I think you are onto something with your image filter idea. According to some of the stuff they are claiming is gravitational lensing. Yeah, it's a lot of processing goes into those photos. James Webb seemed to have even more artifacts like that. Yes, well, it has to fill in all those seams, those gaps between the little hexagons. It has to do a lot of fucking around to take out all the aberration and all the diffraction created by all the edges it has inside of its mirror. It has a lot of fucking seams in it. So, and I'm just saying that there was another guy who, I can't remember the name of his channel, but he actually analyzed some of the lensing images and he found exact duplicates. Like you would see an image of a stretched galaxy here in the horizontal frame, and then exactly at 90 degrees you'd see exactly the same image. And you're saying that's clearly an artifact being created by some algorithm. Some algorithm has made an error and it has, forced the existence of one of those images. All right, yeah, a lot more processing to put together the hexagons. It is impressive. I mean, you got to say, I didn't think the fucking thing was going to work, frankly. So I give them credit that they made the thing work. I don't know how long it'll work because it still seems way too fragile to survive out there. But, you have to give them credit. I mean, I just figure a golf ball of something is going to hit it, and it's just going to rip holes through it. But I just mean that their own science kind of says things and they just don't pay any attention. So yeah, if you ever look at the Einstein ring kind of images, you'll see the rings aren't even round. I mean, fuck. You know, how do you get non-round rings? You know, in gravity, very, very strong gravity is not going to be oblong. That ain't going to happen. All right, anyway. If it really was gravitational lensing, the exact same image should show up for the Hubble and the JWST. Well, I wish they would do, you know, they don't even organize this data very well, because what I'd love to do is show us the images that are 15 years old, then the same place 10 years later or 5 years later, the same place 5 years later, and same place 5 years later. That's what I would like to see. So you could compare what changes take place. And but they don't really do that. So it's, again, it's a data you know, you really can't scrutinize the data very much, because they really don't make distinctions between you can't even tell how much the image was processed. I mean, some are double processed, triple processed, you know. So there really isn't any way to scrutinize the data, you know, because you're not given enough information or enough context. You know, and some of the images are made out of multiple, a giant number of individual images glued together, which is also highly dangerous. Let's see, there are some images like that comparing the same thing, but most of them are comparing similar types of things, not the exact same object. Yeah, well, I just want the same place in space. You know, that would be nice if they just focused on a place and said, okay, we're going to look at that again next year. And then we're going to look at it again the next year and see how it grows. You know, that would be nice. But yeah, that whole idea of stitching images together, you know, anybody who's done any of that kind of stuff, I used to do some of that. You know, yeah, you're really fudging the edges. You know, you're just basically telling the computer, make up the edge. You know, create an average between the two images. So a lot of crap can be created doing that. All right. Let's see. I find it very strange. We spend millions of dollars sending probes and satellites to dead planets like Mars. Well, the fact that the Mars thing is so stupid was we did it in 1980. They really haven't done anything on Mars that we didn't do in 1980. Yeah. I mean, this roaming around thing is such a minor improvement, and not focus of providing how energy works in space using tests. Yes, it just is amazing that the elemental physics is not a subject, and all they care about is, let's go find a living thing on Mars, even though the probability of its existence is insanely unlikely. You know, it's just you know, it's like, oh, let's go find a lottery ticket. Yeah, or let's go find the needle in the Martian haystack. Let's shoot a needle to Mars and have it land randomly, and then let's go look for it. Sounds like a great use of our time. Yeah, it's just all, like I said, it's all this pop culture invading science. It's just turned it into shit. It's a game show now. It's not science. The whole idea of, you know, the devoted brain trying to find the truth is just so lost in trying to find a bunch of flowers that'll pop out of a hat. You know. Do the best magic trick. We are using resources that go nowhere. Like, even if we find a microbe on Mars, like, what the fuck will that do for us? Well, I guess it would be interesting just as a, oh, fuck, the universe is a mess. You know, there's probably some planet somewhere with poor little puppies that are in terrible shape and they really need to be rescued, so we have to spend trillions of dollars and go on rescue missions. I mean, in my opinion, that would be my obvious concern. If there was life in the universe, it's clearly all stupid life, and oh shit, it probably needs to be rescued. It needs a pillow, it needs these basic little things, in a water dish, in a food dish. It needs all this stuff. Come on, we have to go rescue it. There would be something for us to do in the universe, and it would be to go out and be, healthcare professionals. We should travel the universe with our bag of penicillin, try to save them all kinds of horrible grief. Morphine and penicillin. But, I don't want to get into that whole conversation, but there's so many stages to, there's so many plateaus in the evolution of life, impossible plateaus, and obviously intelligence is an impossible plateau. Once you have single cell life, having, multicellular organisms, huge plateau, didn't happen more than once on Earth, all of the arguments where you could just say it only happened once. So on this junkyard of DNA, a planet absolutely covered with the stuff of life, events only happen once, in billions of years, in 4 billion years once, 4 billion years once, 4 billion years once. You can just, there's probably 1,000 of those one-time events that are critical to the next plateau of evolution. I mean, even the word life doesn't mean anything, right? I mean, single cell organism, my cells are alive, technically. I'm alive, technically. That's like saying a brick and a building are whatever, building, some word, You can't use the same word to describe bricks and buildings. That's kind of stupid. So even our language doesn't even come close to being coherent to the subject. I mean, that's how poorly we understand life, is that we don't even understand that we need to have two different words for single cells and then multicellular organism, because the two things are fundamentally different. So technically, if you find a single-celled organism on another planet, you haven't really found life. You found you could call it proto-life, but it's not really a living thing, because all the things that we're worried about being living are the things that are multicellular organisms. They're buildings. They're not bricks. I mean, the fact that I even have to make that argument, right? Isn't that just evidence of just how dim people's scope is? I mean, just how dirty their telescope is, that they really can't see shit. I'm not saying that I saw shit, 20 years ago. I hadn't thought about that subtle distinction. I mean, well, I can't say I hadn't ever thought of it. I might have. I just didn't think it was that important. And then yes, in hindsight, when I became aware that this game I'm playing is really about the welfare of all the living things in the universe, it's not a single-player game. Once that became clearer and clearer, it became more obvious that these distinctions are really important. Because I don't have to worry about single cell crap. It's not doing any of this sensing, feeling. And if it's not feeling, it's not a concern. I mean, it really just doesn't matter. It can only look like it matters. It's kind of like the Terminator sinking into the molten metal. You just don't want it to happen, but you can understand it can't mean anything, right? He's only pretending to be alive, you know. He's not really doing it. But it just shows how triggerable our emotions are and how corrupt, you know, how much it can corrupt your judgment. But there's the little shots at precision are all over the place, right? I saw some icon for a video the other day about worms that eat plastic, and it wasn't a worm, it was a grub. But I guess they didn't want to say grubs that eat plastic. You know, it was clearly like a mealworm. You know, mealworms aren't worms, they're grubs. You know, and you know, they will be beetles. They are going to they're not the end product. They're a you know, proto thing, you know, where a worm is a worm. Worms don't turn in anything, you know. It's just kind of irritating because, you know, it's a science video. It should be, you know, it should be more correct than that. NASA knows that they use MV to move in a space, or am I wrong? Well, I'm saying that, yeah, NASA, I don't know why the NASA scientists are so quiet on the subject. I mean, there was only that one guy who came out and said, you know, we've never seen bending outside the sun's corona. They don't have any images of any light bending because all the experiments that involve the bending of light happen in the dust of the sun, the dusty atmosphere. And so I don't know why more astronauts and other people don't come right out and say that this isn't just because Einstein is wrong, it's because Leibniz is wrong, okay? I mean, momentum works. I mean, they really should be pushing momentum as an idea because their whole science of the universe, their whole understanding of the universe is completely run by momentum. Momentum does everything. Once they're in space, right? Momentum is everything. There is no kinetic energy that has any use. So yeah, I don't really have an answer for that, why all the NASA scientists aren't more keenly aware of the fact that we're not using modern science. So maybe it's crap. You know, if we're not using it, I mean, who should be, right? I mean, we should be using all the science there is, right? How come we're not using this big pile of science? Oh, it's because it doesn't work? Could that possibly be the answer? I mean, I have to say, it's hard to imagine that all these people who are smart, they have gained a lot of knowledge, done a lot of and none of them are a little suspicious. I mean, to apply a little bit of scrutiny, to dig a little bit. I mean, you don't have to scratch at MV squared very hard, you know, in terms of its history, to see that it sucks. I mean, that it wasn't proven by any preponderance of the evidence. There was no great pile of evidence that proved this crap. I mean, it's just simple friction experiments and dropping shit into clay. I mean, it's really, you know, it's really not enough to declare, you know, kind of an extreme statement that's, you know, it's sort of just saying that Newton, Galileo, and Descartes somehow were missing this vital piece of information. Yet they got right answers without it. How curious. Yeah, well, like I said, dishonest and stupid, you know, that's the hard one, right? So, I mean, that's the whole problem with intelligence, is it's very, idiot servant thing. You can be highly intelligent in terms of your world knowledge, but you can have no knowledge about how to get along with people in Arkansas or something. You know what I mean? It's all selective intelligence, and maybe that's part of the problem. Is people have disproportional knowledge in subjects, so it's not enough general knowledge to be able to see big pictures. So all they can see is the focus, the part they focused on, they're really expert at, but the rest of the universe is sort of, I don't know how that works. Something like that. And I suppose that my focus was unification from the very beginning. I mean, my underlying default assumption was that whatever the universe is made out of, it's simple and it's redundant in the sense that same things are doing different things. So as soon as you know that gravity and electricity and light and magnetism are all moving at the same speed, it's sort of a reasonable deduction to say it's probably a good area of investigation anyway to assume them to be the same thing, just doing things differently. And so try to figure out a way they can be different and be made out of the same thing. And, that's my advantage. I would argue it's an advantage. I would argue I am right, and it's because of that advantage that I'm right and everybody else is wrong. I mean, it seems such an obvious conclusion, right? I mean, I guess if you just took like 1,000 scientists and then you suggested to them that because gravity moves the same speed as electricity, as magnetism, as light, that all that stuff is made out of the same thing. Maybe they've never considered it. I don't know. How many out of 1,000 would say, oh yes, I've thought about that? I don't know. It just seems, I'm just saying, to me, it's a beacon. It's, it's hard to ignore that fact. It just sort of does say, this means they are the same thing. It sort of just tells you whatever it's made out of, it's the same stuff. Let's see. It seems like if you want to be seen as an intellectual, you need to be involved pop culture to gain respect. Well, you have to network. That's, clearly the game is all about networking. I think this happens like even in the acting community. You have to be buddy with the directors and the producers and all this kind of stuff. You have to be a likable person or you're going to be blacklisted and blah blah blah. I think there's a lot of that in all of this. It's really not about credentials or the quality of your work or the initiative you put in or any of that crap. It's just such a subtle line. But you see weird things, right? Okay, so this guy who I played the entanglement video of, he has like 100 and whatever subscribers, 1,000. And his videos are all over the place. So he's had viral videos that got over 1 million views, and then his regular videos get 3,000. It doesn't make any sense, right? I mean, 1 million to 3,000? I mean, that's, those kind of things are just kind of bizarre. Channels with 1 million subscribers, and you'll look at the video and last week's video and 10,000 people watched it. You're like, what the fuck? Yeah, obviously the media, okay, just goes with what the name recognition thing. So as soon as people have some name recognition, they just want to keep putting the name, and the name gets more and more recognizable because they keep shoving it in your face. So that's what the Degrassi Tysons and the Kakus are. They're just the people who, gained name recognition. It's the same thing. It runs like political campaigns, right? People will say you can't run for president because you have no name recognition. You're like, well, that's not a good reason somebody shouldn't run. Shit. Of all the stupid reasons, that's about as dumb as it gets. Well, Akaku is now gone, pure wacky. He was always a dreamer and a hoper and a wisher. But when he starts defending UFOs, you're just like, oh, fuck. You know, he has drunk way too much lead rice wine or something. I mean, it's way too much lead in whatever he's eating. You know, he's gone. I do find it interesting that Maxwell said magnetism and electricity travel at the speed of light and concluded light was an electromagnetic wave. Well, he should have concluded the other way around, right? But anyway, then gravity travels at sea, but no connection there. Well, I'm just saying that the idea of he could have understood light as being a code sent through space, just like the code being inducing electricity, right? You know, and instead they turned the code producing the electricity into this electromagnetic photon bullshit. But yeah, the connection is just so like, whoa. I mean, to me, that's just, well, I've already said it. I mean, it's a fact that seems beyond coincidence. And it sort of blows up bent space, right? But you'd argue, why does bent space function at the same speed as electromagnetic radiation? I mean, isn't that a bit of a coincidence that this idea of a bent geodesic is somehow moving at the same speed as stuff that's not a bent geodesic? Yeah, I don't know. That doesn't sound very reasonable. Just coincidentally, you know, the completely different mechanism moves at exactly the same speed. Yeah, come on. Too silly. All right, let's see. What do we got? Oh, 2:16. Yeah, so a few more minutes, and then I guess it's time to go. Get on with my charming day. Let's see. It's pretty frightening that people actually respect when he talks about string theory and trying to get people on his side of logic. Well, obviously, there's not much logic to worm theory. You know, worm theory. No, we should call it grub theory. Yeah. I mean, it's just, you know, I just don't. It just seems so unreasonable. I mean, the thing that string theory is, the major thing it's doing, is it's telling you the energy in the universe is coming from elemental things moving. So the objects are moving, okay? And that the ether is dead and it's moving the ether. So the things are moving, that's moving the ether, and that's communicating the movement. When doesn't that seem exactly backwards? Like, no way it would happen that way. You know, jellyfish theory. So the elemental universe has a jellyfish in it. You know, jellyfish it all the way down. I mean, that seems so much less sensible than the idea of the discrete tiny energy being the little dust in the universe. That has the energy, and it gives the big things motion. That makes so much more sense, in my opinion. But the whole way they talk about it, you know, they turn into string theory. It's like little violin strings, and they get plucked, and they create the little waves of... I mean, it's, just, it's such baby talk. You know, that sure as hell doesn't explain a laser beam. It's even the geometry thing, right? Because the geometry gets kind of backwards when you try to make the checkerboard and then put the universe on the checkerboard, right? Because the checkerboard doesn't have the right geometry, right? I can't make a checkerboard where I have straight lines in all angles, because I end up with that stupid diagonal problem, right? Where the diagonal is only 3 squares, but it's, you know, 5 units of distance, you know. what the fuck? How can I do that? I can't. So you can't make any geometry, okay, out of an ether to make it possible to send energy in a straight line, because it won't be a straight line. It's going to get corrupted. So the only straight lines are here and here, and everything else has to be a crooked, an least line. So you're just saying, doesn't that just tell you that the universe isn't happening on a pre-existing geometry of something? It's a geometry that is no geometry. The geometry is coming from the shapes of the matter. It's coming from the geometry of the matter, not the geometry of the space. Sorry, I'm not sure. You've said it elsewhere, but was space created with the bells? I don't have any interest in origins, frankly. Don't think it means a damn thing. I think the universe is oscillating. So it just gets a tiny bit, as I've sort of pointed out to you, the energy is fixed. So the idea is that the more energy that goes into compressing matter, the more energy is used moving the matter. Therefore, there's less energy on the outside, so therefore everything expands into the less energy on the outside. And as things expand, what they're doing is creating more energy in the outside that's now going to push them back in. So it's just going wee woo, and so that's all there is. The gravitational constant does in fact change over time, because the universe gets to be more energy on the inside of galaxies than on the outside, and then it goes back to being more on the outside than the inside. And it's only a little bit more. So the galaxies just do this, and that's all that's happening. But creation is just too... There's no way we can do anything with it, right? I could just tell you that, let's say we know we evolved, so you could argue that the universe evolved. And what did it evolve out of? Well, just like evolution, it evolved out of errors. Okay, so the universe was nothing, and something is the error. Okay, and whatever created the error, well, it's an error, so now you can do it again, and then you can do it again, and then you can do it again. So over gazillions of bazillions and zillions of years of time, maybe the universe makes one electron every 10 zillion years. And that's all that changes. One more electron poofs into existence. And that's all that's happening. And so the universe is just doing this bigger thing, because it's adding electrons at this incredibly slow but inevitable rate. But I can make up all kinds of stories, but that's all I can do, right? I can just make up a story. But I'm just saying, obviously it wasn't poofed by a god, so, yeah. There's no organization built into it that's at all has any destiny, any function. But yeah, it's not a question made for... It's not a question. I mean, there's just I guess it's another curious fact that you can ask a question for which there is no answer. And I guess I'd say this is one of those problems where I don't know if the question's answerable. It's beyond what we can see from our location. So we're stuck like the primitives trying to figure out what the sun was or what the lightning was. We're just stuck with just too little information to be deducing origins. I mean, all of their Big Bang crap comes out of this stupid light retardation thing. So I guess what I would say to you that you haven't heard from me is that I would argue that light is simply retarded in its progress through space, and that's the cause of the redshift. There are, in fact, a lot of little stranded helium and hydrogen atoms in empty space. I guess mostly hydrogen, but anyway. And every time a photon goes through one of those transparent atoms, it in fact hits electrons, and it gets slightly deflected, and Compton scattering. The end result is a change in its wavelength, a degrade in the wavelength of the light. So every time it hits, theoretically, a hydrogen atom, the photon would lose some of its frequency. So it would, lose a nanometer of frequency. And that's why things far away are redder, is because the light has in fact encountered more hydrogen atoms. And the things closer to us haven't encountered too many, and therefore their frequency hasn't been degraded. I would argue that a simple explanation like that, okay, it works for explaining redshift. And you don't need to speculate about Big Bangs. But you could argue that their own theory of a Big Bang is so ludicrous, right? Because it has this stupid bit in it where it explodes and then it explodes 1 million times in an instant, without taking any time. Like in an instant of time, it just automatically got 1 million times bigger. Does that make any sense to you? It doesn't make any sense to me. Alright. Problems with the expanding Big Bang model are insurmountable at this point. Well, there's a lot of reason to say they've turned the Big Bang into something much more complicated, right? So you're just saying they've turned it into such a wacky theory, like somehow we moved faster than the cosmic background radiation. How could the cosmic background radiation still be around? It's going the speed of light from the explosion, right? We're going a lot slower than the speed of light, so how the fuck could the cosmic background radiation be in the background anymore? It can't be there, right? That doesn't make any sense. So I'd argue the cosmic background radiation is something completely different than remnants of the Big Bang. I think that's a silly theory. I think it's just the background radiation. I think it's just the fact that the universe is full of little radiating bits, and all of that added up is the cosmic background radiation. And it's coming from far away, and so therefore it's been turned into microwaves. Alright, so we'll call that enough of a video. Well, 3 more minutes might as well. 3 more minutes won't hurt me. Maybe somebody will say something insanely, profoundly interesting and intriguing. I mean, you could just type the words interesting and intriguing. There, you accomplished the task. Dark energy. See, well, dark energy is just, that's Einstein's fudge, so who knows what the hell that is. Non-baryonic matter, right, dark matter, inflation, galaxies older than the Big Bang, surface brightness problems. Brightness problems are just a big, huge problem, right? Because, they find galaxies that are 1,000 times bigger than they can rationally account for, and, blah, 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 blah. But, whatever. The problem is all of this is storytelling. I mean, it's really just not science. It's just storytelling. It should all be fine. Everybody can tell a story, but don't pretend you have a preponderance of evidence, right? They talk like on that stupid PBS show. The guy talks like this is all proven. And it's like, what the fuck? It's a long way from proven. Anyway. I mean, that's kind of a key thing. It's, they really shouldn't. That's part of the whole thing that makes it all so arrogant and obnoxious, is they talk as if they've proven this Jesus to exist. And it's just a story. Alrighty then. So, till the next time, and such, and so forth and whatnot. So, I appreciate the contributions, and we will no doubt be back with some sort of crap to have to counter-argue, whether it be accusations of my ignorance and evilness in exploring these questions, or some other crap like that, or whether it'll actually be a piece of evidence to scrutinize for its brilliant credibility. like smashing carts into crackers. Such a brilliant idea. Ooh, gee, I wish I thought of that. Oh, God, this is so bad. Anyway, till the next time and such and so forth and